Hello students, welcome to ShirtBack Academy. This is going to be our first lesson in the ITF Plus U61 IT Fundamentals course. We're going to be beginning with Module 1, which is IT Concepts and Terms. And our topic for this lesson will be covering Section 1.1, which is Notational Systems. Let's begin. Notational systems are numbering systems. The first numbering system we're going to discuss is decimal notation. Decimal notation is a base 10 numbering system. That means it uses 10 single digits. It's our normal counting system. The 10 numbers we use in decimal notation are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We change a counting place once we reach 10 of the column that we are counting. Over here to the right, we have an example of a traditional decimal number. We also have listed the different places that we count as we go either to the left of the decimal or to the right of the decimal. We don't go from one column to the next until we reach 10. That's what we mean by the power of 10. With decimal notation, all numbers to the left of the decimal are whole numbers. All the digits to the right of the decimal point are fractions of a number. We use decimal notation usually with math problems and computing calculations. Our second numbering system is binary notation. You've probably never used binary notation before. We're just going to briefly introduce it to you so that you're familiar with it later in the course. Binary notation is a numbering system that uses only two digits, 0 and 1. It uses no other numbers. Each number in binary is called a bit. Bit is short for binary digit. Each bit will have a value of either 1, which we call true, or 0, which we call false. 8 bits equals 1 byte. Over here to the right, we have an example of what's called an IP address. An IP address is the network address for your computer. You'll notice that here in our example, there are 4 groupings of 1 and 0 digits. Each segment is separated by a period. And above, there are different values. The values that you see are the calculation of the ones in the address bytes. The question is, how do we solve that? How do we get to those values? It's by called the power of 2. You'll notice that in each segment we have 8 values. We start with the first value, that is, over here on the table we have an example of the values that we calculate if the number that we see is 1. If a 1 exists, we calculate the number. If it's 0, we don't. So over here, here's an example. In our table, we have 8 zeros. So here in our first column, we have a 0. Its value is 1. And if we give it a value of 1, we bring the value down. Here we have a second 0. Now the value is going to be 2. If we put a 1 there and bring the 2 down, we now have a value of 1 and a value of 2. As we keep going through our table, we have examples of where we have zeros or ones. Anytime we bring the value down. Once we've gone through all 8 bits, then we calculate all of the numbers that we brought down in our table. As you get used to binary notation, you'll get used to doing some of this in your head. So then when we look at our example again, we can see over here in our first segment, the only one we see is here at the first digit. So it's only going to have the value of 1. No other ones exist. Here, we have ones everywhere except for the first one. So if we added up all of our numbers, 128, 64, 32, all, and so on, we get 254. Where the ones exist in the segment of the 8 digits will determine the value once you've added them all together in your address. Our next numbering system is hexadecimal notation. Hexadecimal is a numbering system that uses 16 digits. Hexadecimal uses the traditional 0 to 9 integer numbers. However, the numbers 10 to 15 are represented with letters. Let's take a look here at our table. You'll see that we have examples of binary and hexadecimal. Hexadecimal goes from 0 to 9, but when it gets to 10, it uses the letter A. It uses B for 11, C for 12, D for 13, E for 14, and F for 15. These are the corresponding binary examples for each value. Hexadecimal is used with a newer form of internet addressing called IP version 6. With IP version 6 addresses, they contain 16 bits and separate their segments with colons instead of periods. We'll talk about hexadecimal later in the course. ASCII is a representation coding standard for electronic communications. It was originally used for telegraph code. Over here to the right, we have an ASCII coding chart. You'll notice here at the top, we have hexadecimal values from 0 all the way to 15. We go from 0 to 7. We have 8 different values, 0 to 7, and 16 up here, 0 to 15. There are 127 different character types within the ASCII standard. The first 32 are what are called control characters. Control characters are the numerical codes that manage devices and printing formats. The remaining 95 characters are what are called the printable characters. These are the letters, numbers, symbols, and punctuation marks that are outputted and printed on the paper. Operating systems typically will use what's called OEM, or Original Equipment Manufacturer, to print their code pages for OS processing. Unicode is an IT standard that encodes, represents, and handles text output. Unicode provides rules for features such as left-to-right text display, collation. Collation is the numbering of pages in sequential order, 1, 2, 3. Unicode also provides rules for indenting and tab features. There's 2 types of Unicode that are commonly used. UTF-8 is the Unicode standard used for the internet traffic, used over the HTTP protocol. UTF-16 is the main operating system processing standard for Unicode data. One popular place you'll see Unicode data is with emojis. That will conclude this lesson. If you have any questions about the contents of the lesson, please review the downloadable course notes and the exam objectives from section 1.1. In our next video, we'll talk about section 1.2, data types. We appreciate you following along. We'll see you next time. Enjoy the rest of your day, everyone.